Hello everyone, welcome to PostgreSQL Crash Course. This is day one. This is your host Mohan, and you can connect me on WhatsApp. My number is +91, that is a country code, and my number is 9021776041. So I will create a WhatsApp group, and it will be good for the networking as well as I will also share a few important information in WhatsApp group. So let's begin. So let's understand what is PostgreSQL. So PostgreSQL is a free and open source object-oriented database management system. So as you know that it is free and its community edition is available on the internet to download and use for free. It is open source. It means its code is available publicly and you can download it. You can modify it as per your requirement, as per your need. You can use it and modify. And what is object oriented? So this is a database management system which is following the concept of object oriented language. So for example, this inheritance is supported in PostgreSQL. So if you create a table and you can refer that as a parent table, you can create a child table with you can refer from the parent table, and this child table will inherit all the properties of parent table. So this is how it is following the object oriented concepts. And PostgreSQL started its journey in 1986. So it is initially called Postgres. It is developed as a research project of University of California at Berkeley. Michael Stonebraker and his colleagues developed Postgres. And Postgres is a cross-platform and it supports multiple operating systems. It supports Windows, Solaris, Linux, Mac OS, FreeBSD, OS X, etc. So it has support from multiple operating systems. PostgreSQL features transactions with atomicity, consistency, isolation, and durability, and that is called the ACID properties of transaction. As a DBA, you must be aware of this ACID properties because it's being asked in multiple interview questions. So let's repeat for you guys. So what is atomicity? So atomicity is something, or atomic transaction are something where it is treated as a single unit. So either all the transaction will fail or it will succeed. If any part of the transaction is failing, it will completely roll back the transaction. So that is called the atomicity. Uh, what is consistency? A database should be in the consistent state after the transaction completion. Database may move from one consistent valid state to the another one. So for example, if you want to transfer some amount from account A to B, so the total value of the amount should be the same before and after completing the transaction. So it will make sure that the database or the data will be in the consistent state. Third one is isolation. So isolation basically ensures that all the transactions are isolated. It means they do not interfere with each other and they execute independently. The last one is durability. So once a transaction is committed, the changes are permanent. So in case of database crash, those transactions can be recovered. So how this durability is achieved in database management system, we do logging, we can do checkpointing in database management system to achieve the durability. So the next is MVCC. So PostgreSQL manages concurrency through multi-version concurrency control. We have a whole slide for this, so I will discuss it in some time. So just to repeat the concept of transaction violation. So what are transaction violations? When a transaction doesn't follow or doesn't adhere to the asset compliance or asset properties, that is called the violations. And if violation happens, it will lead to the database corruption or data inconsistency. So there are mainly three types of violations. One is dirty read, second one is non-repeatable read, third one is phantom read. So what is dirty read? So a dirty read refers when a user reads the data that is being modified. So for example, if there is a transaction 1 or transaction A that is modifying the data, it is modified the data, it has modified the data, but it is still not committed. At this time, if a transaction B tries to read the data, that data is called the dirty data or dirty read, because transaction A still did not commit the data. It can modify it further or it can roll back. So whatever data block transaction B is reading, it is a dirty read. Second one is non-repeatable read. A read query will get different results if query again. So that is called read non-repeatable read. So for example, transaction A read a data and the value is 10. After some time, transaction B modifies the data from value 10 to 20. And again, if transaction A read the data, it will not get the value 10 because it has been modified as 20. It will get value as 20. It is not the same as before. So this is called non-repeatable read, where you are not getting the same data when you try to read again. The third one is phantom read. So if you are querying employee table, for example, if your table has 5 rows with employees and their salaries are 10K, 20K, 30, 40, and 50K. So you have 5 rows, and if you run the query select a star from employee where salary is less than 30K. So at this time you will get 3 rows, 10K, 20K, and 30K. Now, another transaction modifies the salary of an employee from 50K to 25K. Now, if you run the same query again, select a star from employees where salary is less than or equal to 30K, you will get 4 rows this time, because that rows which was modified from 50 to 20, it will also come in the output. So the range you are trying to query, it will give additional row in output. So that additional row or additional record is called phantom record or ghost record. So based on those transaction violations, we have different isolation levels. So these are different isolation levels and allowed violations on those isolation levels. So we have 5 isolation level. One is read uncommitted. So in this kind of isolation level, every violations are allowed. So you can have inconsistency in data. So it allows dirty read, non-repeatable read, and phantom read. In case of read committed data, a read committed isolation level, you can not have the dirty read problem. Still, you can have non-repeatable read and phantom read. So this read committed is our default isolation level of Microsoft SQL Server as well as PostgreSQL Server. Third one is repeatable read. It will not allow dirty read violation or non-repeatable read violation, but it will still allow the phantom violation. The other two, or the last two, are the snapshot and the serializable, and those do not allow any violations. However, those isolation level are very strict, and if you put your database management system in those isolation level, you may find that there are a lot of blockings because it will not allow any of the violation. So choose your isolation level very carefully as per your load. So now what is MVCC? So MVCC refers as multi-version concurrency control. So it is basically a mechanism that allow multiple transactions to access and modify data concurrently without blocking each other. It will ensure the data consistency and improve the performance. So how it works? So MVCC basically works in the concept of versioning. So when there is any update, it will not override that particular data block, but it will create a new version of data block each time it is trying to update. So you can have multiple version of data. Some can be the older one, and one can be the recent one. So in case of read operations, so read operation will go and check the latest version of snapshot or latest snapshot of that particular data, and it will read that particular data, and this data will always be the committed data. In case of write operations like update or delete, it will basically, before modifying the data, it will create a new version of data. Once it is committed, it will update the older version of the data is outdated, and the newer version will be the latest one. So this is how it will work. This is the whole concept of multi-version concurrency control. So what are the benefits of multi-version concurrency control? It will have the improved concurrency, right? Because we have different versions of data. So multiple transaction can read the data from latest version. It will have reduced log contention, as like we have different version of data. So whenever any transaction is trying to modify the data, it will not lock that particular data, but latest version of that particular data block is available to read. It will have data consistency because it will not allow any read operation to read the dirty data, because it will always read the committed data. So now, what are the pros and cons of PostgreSQL? So as I said, PostgreSQL is a free and open source ODBMS. We know that it is open source. We have already discussed it is free. So here we basically work on the community version of PostgreSQL. So it is free to use, but for enterprise, for example, if you want to use it for the like large enterprises where you want support, you can take support from companies like Enterprise DB. There's a company. So in case of Microsoft SQL Server, for example, if our team is not able to resolve any issue, we go and we create ticket to Microsoft. So that's called the Microsoft support ticket. It is paid service. So in PostgreSQL, as it is free and there is no company which is providing the licenses, but if you want the support, you can take that service from organization like EDB. Second advantage of PostgreSQL is it is extensible and it is ACID compliance. So we have already discussed about ACID properties. It complies the ACID properties and it is extensible. So what is the meaning of extensibility here? So for example, if you download the code and if you find that there is one functionality which is not available in that source code, and if you have the team of developers, you can develop that functionality. So you can extend it as per your requirement. There are multiple things which you can do. You can create your own data type, you can create your own function. So it is how it is like extensible. This PostgreSQL is highly extensible. It has a strong community support as it is being in public use since 1986. It has a community of thousands of people. So if you have any issues in your operations, you can just ping there. You can post your questions, maybe in a 1 day or 2 day, you can have a reply. So that's why, like, if you are using it for your enterprise, it is recommended that you take support from a company like EDP. So this PostgreSQL is SQL compliance, and it has a large data type support. It has the advanced security. So this supports the security at parameter level as well as the app level security, and it also provides security features including data encryption, SSL, TLS, and granular access control. It has language support for Python, Java, Perl, .NET, Go, Ruby, C, C++, etc. There are some limitations as well for using this PostgreSQL. So one thing is no support for security patches. In case of Microsoft SQL Server, every 90 days, I think Microsoft releases the security patches. So it will take care of all the vulnerability which is there in the current version. But in case of Postgres, as no company is owning this, it is open source. Everyone is using the community edition. So there is no regular security patches. So this performance sometimes can be a problem. It can be slower as compared to other RDBMS, and limited documentation. So it really has a limited documentation, as in case of Microsoft SQL Server, we have MSDN, where we can find deeper documentation or in-depth documentation in each topic. In case of PostgreSQL, it is difficult to find the documentation for the advanced features. Now there are some naming conventions which is different than other RDBMS. So here, whatever we call tables or indexes or indices in SQL Server, it is called relation in PostgreSQL. Row will be called as tuple. Columns will be called as attributes. Data block will be called as page when it is referring on the disk. And this particular page will be called buffer when this block is in the memory. I think it is pretty straight. So there are particular limits. However, we will not be using those particular limits. Those are the top limits or upper limits. So database size, you can have unlimited as size of the database. Number of database will be almost 4.3 billion. I don't think anyone is using this. And relations or tables per database, it is around 1.5 billion. Relation size or the table size will be limited to 32 terabyte. Columns per table will be 1600. So this is it for today. Tomorrow I'll try to cover the architecture of the page and the uh, architecture of the PostgreSQL. So I hope you will go and check further details about whatever has been discussed today. So enjoy your learning and enjoy your day. Thank you.